Hello, everyone. We will continue with the concept of nonlinear SVM. We have seen polynomial kernel, and as we have seen, by adding the polynomial features, we can convert our dataset into the dataset which can be linearly separated. As we explained, there are some downsides for technique of adding polynomial features. Today, we want to see another technique, which is called RBF kernel or Gaussian RBF kernel. This technique is used to tackle a nonlinear problem by adding features which are computed using similarity function that measures how many each instant resembles to a particular landmarks. In order to measure the resemblance of the data points and landmarks, we need a mathematical tool. The mathematical tool that we use to evaluate the resemblance is called the Gaussian RBF, and it's defined by using this function. And here, as you can see, you have two vectors which are p-dimensional. You will define a function, e to the power of e here is a exponential function, e to the power of negative omega times the or Euclidean rule distance between x and y. So if the formula looks strange, don't worry about this. We will see the example. The only thing which is important to understand is measuring the resemblance needs a mathematical tool. It means that you need to have the mathematical tool to measure the resemblance between 2 points. This is this function is one technique which is used to measuring the resemblance between 2 points. So let me explain how this function can be used on this famous given data set that we used in another video. These points are given, then here, as you can see, we have points on the one-dimensional space. We have just one coordinate for each point, -4, -3, -2 until 4. And we will choose two landmarks. Landmarks that we choose are -2 and another are 1. Any landmarks, any points can be used to define a landmark. The number of landmarks also should be evaluated. Here, as you can see, I am using 2 landmarks. We will see that more landmarks can be used, and we'll see that if you have more landmarks, we will get the more complicated model. But here, let's start with these points, and I am choosing these 2 points, which are highlighted here as landmarks. Then here, there are 2 landmarks, and I have chosen these 2 landmarks randomly. So now what is the goal? The goal is to evaluate the resemblance of each data point with respect to each landmarks. Then let's do this on one example. In order to do this, we will use Gaussian RBF. When we want to use Gaussian RBF, the invariant gamma should be chosen. Then here I have chosen 0.3 as the invariant gamma. Then when we have this, if we choose, for example, x1 equal -1, I'm saying x1 equal -1 means if we choose this point, x1 equal -1, and if I evaluate, if I evaluate the resemblance of x1 to each landmarks, then these values can be evaluated. For example, if we consider the resemblance of -1 to 1 landmark, say, because here there are 2 landmarks, one of them is -2, another is 1. Then if we want to use the RBF formula, when we want to evaluate the resemblance, you have to find the distance between the point that you have chosen and each landmark. For instance, if we find the distance between -1 that we have chosen and these landmarks, then if we want to find the distance here is 1. And if we want to choose, if we want to find the distance between this point, -1 that we have chosen, and another landmark, as you can see, distance is 2. Then if we plug in the formula, I have chosen gamma as 0.3. Distance to 1 landmark was 1. Then here we have 1. Then -0.3 times 1 is squared. If we evaluate this, it is approximately 0.74. And distance to another landmark was 2. Then here, if we square it and multiply by 0.3 and by -0.3, then here, if we evaluate this, we will get 0.3. So Then the resemblance that we have evaluated with respect to each landmark for this point, x1 equal -1, is 0.73 and 0.3. So by using the same method, RBF similarity, RBF resemblance can be found with respect to landmarks for all points, and thus the feature x2 and x3 for all points can be computed. Exactly the same thing that we did for -1, we can continue calculating x2 and x3 for all other points. So if we plot these x2s and x3, which can be evaluated by using Gaussian RBF, on the diagram, we will reach to this diagram. Then you can check this. This is easy. Then here we can see that I have evaluated two new features, x2 and x3, for all points. And after that, when I plot these points on this diagram, then here, as you can see, these points can be separated linearly very easily. So then, as you can see, this method is mathematically more complicated than polynomial kernel that we had before. But again, the important question which should be answered is how we can choose landmark. Because in the previous example, I have chosen 2 points. The question which can be asked here is, how do we know that 2 landmarks are the best? And how do we know that those points that I have chosen as landmarks are the best? These are very interesting questions. The simplest approach that we can have to create landmark is to consider the location of each point as the landmark. This creates many dimensions. For example, if you have 10 data points, which is not for sure a big data set, if you consider each point as the landmark, you will end up with 10 dimensions. Because as you may remember in the previous example, when I have chosen 2 landmarks, we ended up with 2 dimensions, x2 and x3, 2 features which gave us 2 dimensions. Then if we choose, for example, 10 landmarks for each data point, then we will end up with 10 dimensions. And it is very true that we increase the chance of transforming the training data set to linearly separated data set. But the downside is that training set with m instances and n feature gets transformed into a training set with m instances and m feature. And it can be very complicated. Then if your training set is very large, you ended up with an equally large number of features. And this is one important thing that we need to understand, that although choosing each point as landmark can give us, in many cases, can give us a data set which is linearly separable, but it is very likely that if you have a very large data set, say, for example, you have a data set, I don't know, with 1 million instances, then if each instance is considered as landmark, you will end up with a data set with 1 million, for example, dimension. Therefore, you will end up with very complicated data set. Then finding landmark and how many landmark is appropriate is very subtle and important question which should be answered. So in this video, I just try to give you the sense that how RBF similarity work and how the function works. But there are still many things which should be explained about landmarks, and especially the number of landmarks. These are some hyperparameters which should be adjusted and which should be evaluated. And there are some techniques that we do not cover in this class. But I just wanted to show you how this RBF similarity work. Thank you for watching. I think it is good to stop.